In today's lecture, we will go ahead and learn other processes of finding real solutions for polynomial equations. If we can factor, then there is nothing better than that. We will go ahead and try to factor polynomial equations. But if we cannot, then we would like to introduce other concepts. One of these concepts is division, long division. And then we are going to introduce a concept which is pretty much similar to long division, but it's called synthetic division, and we will see how these processes will essentially help us understanding and finding real solutions to some of the polynomial equations. So I'm going to skip the instructions and start working with long division because this is something you have already seen. I will talk about the terminologies a little bit. So the factor by which we are dividing. So for example, in the first one, x minus 5 is called the divisor. And if we have something called a polynomial dx and we divide it by the divisor, say small dx, then my answers are going to be of the form a polynomial qx times this divisor polynomial plus a remainder polynomial. Remember, remainder can be equal to 0. And we say in this situation, the divisor divides evenly. So this polynomial qx is called the quotient. And remainder rx, they are going to be of huge importance for us in the process of finding solutions, real solutions for polynomial equations. So let's start working with this problem. I'm going to divide x squared plus 3x plus 6 in the process of long division by x minus 5. Your first step is to write down the polynomials, both the divisor and the dividend, in a way so that there is no missing term. For example, in the polynomial x squared, I have the square term, I have the degree 1 term, I have the degree 0 term. So it is a complete polynomial. If I didn't have one of them, then I have to insert that term with the coefficient of 0. And when we encounter a situation like that, I will show you. I'm sorry. And then you do the same thing with the divisor polynomial. Now your target is to multiply something with the x that will make the product look like x squared. And clearly I understand that if I multiply x with x, then I get x squared. If I multiply x with negative 5, I get minus 5x. In a regular long division, now we are supposed to subtract. So how do I understand subtraction? At this point, you are going to change the signs from positive to negative, from negative to positive, and then simplify. So see, x squared and x squared will cancel each other. I will get 3 plus 5, 8x, and the next term will come along. And I repeat the process. So now you try to determine how much you multiply with the x to get 8x. Well, clearly it should be positive 8, so let's do that. 8 times x is 8x, 8 times negative 5 is negative 40. Don't forget to subtract, and that is changing positive to negative and negative to positive. We will simplify. So we'll see 8x and negative 8x will cancel, and I will get 46. At this point, I will stop dividing because the degree of the polynomial is 0. So this polynomial that we got, 46, it's a degree 0 polynomial, which is less than the degree of the divisor polynomial, as this degree is 1. So that is when we declare that x plus 8 is the quotient and 46, which is, remember, it is a polynomial function, it is the remainder. And we answer our question in the required format. So we say the dividend, the polynomial we were dividing, is equal to the divisor times the quotient, and remember the quotient was x plus 8 in this problem, plus the remainder, which is 46. We can also do a division and write our answers as the dividend polynomial. So dividend is which you are dividing over divisor is equal to the quotient, polynomial plus the remainder over the divisor. There is one other form of writing the answers. Depending on the problem, we will be instructed to choose the proper form. So let's try to solve the next problem. This time you're solving a 4th degree polynomial by a 1 degree polynomial. So it is a 4th degree polynomial, and if you see the cubic term, the 3 degree term and the 1 degree term are missing. So I have to fill them in. How do I do that? I call it x to the power 4. You have the cubic term missing, so insert that with a 0 coefficient. The 2nd degree term is there already. Insert the linear term or the 1 degree term with a 0 coefficient, -8. And then you start dividing. So this time I'm dividing this polynomial by x minus 3. So what I need on the top, something that I multiply with x and get x to the power 4. And I know that that's going to be x to the power 3. So we will get x to the power 4 minus 3x cubed. You're subtracting, so you're changing positive to negative. You're simplifying, so now you are getting x to the power 4 and x to the power 4 cancelling each other. 0 plus 3 is 3, so I will simply say this is 3x cubed. Bring down the next available term and repeat the process. So now I am looking to multiply something with x to get 3x cubed. Well, I need 3 positive x squared, and that will do the work for me. So I will get 3x cubed minus 9x squared. Subtract. Change positive to negative, negative to positive. 3x cubed will cancel each other. 9 minus 5 is 4, so I get 4x squared, and I bring down the next available term, which is plus 0x. Okay, how much I multiply with x to get 4x squared? So clearly the term is going to be positive 4x, so that I get 4x squared minus 12x. Subtract by changing the signs. 4x squared will cancel each other, and you will get 12x, and the next term along is negative 8. So now we will multiply 12, because I have to match 12 times x and have to make it 12x. So you will add 12 with it. So I get 12x, 12 times negative 3 is negative 36. Subtract by changing the signs. 12x minus 12x will cancel each other. 36 minus 8 is 28. So now I have degree 0 polynomial, which is smaller than the degree of the divisor polynomial. The divisor was degree 1, and I'm done with this long division. What does that mean? That means I can now write my answer as the polynomial that we were supposed to divide, which is x to the power 4 minus 5x squared minus 8, equal to the divisor polynomial, which was x minus 3, times the quotient polynomial. And remember, the quotient we got is a cubic polynomial. It is x cubed plus 3x squared plus 4x plus 12 plus the remainder, which is 28. Let's do one more division. So this is a cubic polynomial divided by a square polynomial. So again, we were starting with cubic polynomial. You have the 3 degree term, you have the 2nd degree term, you have the 1st degree term, you have the linear term and the 0 term. So everything is there, and then I'm going to start dividing by a quadratic polynomial, 2 degree polynomial, and all the terms are present here as well. 2nd degree, 1st degree, and the 0 degree. So we're ready to start. First, I need only x that I multiply with 5x squared to get 5x to the power 3, and I keep multiplying. X times x is x squared. X times 4 is plus 4x. Subtraction. So I'm going to change all the signs. Negative. This is also going to be negative. This is also going to be negative. So 5 minus 5 is 0, so they are gone. Minus 9 minus 1 is minus 10x squared. 6 minus 4 is positive 2x. And bring the next term along. And determine how much you multiply now. So now we're going to multiply negative 2, because that will multiply to 5 and give you negative 10x squared. Okay? Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. I changed the signs because I'm subtracting. So again, cancel. 2 plus 2 is 4x plus 11. And this problem, I will stop here. How come I'm going to stop here? Because this is a degree 1 polynomial, which is less than degree 2 polynomial. That's my divisor. So I already have a smaller degree polynomial, and I'm done with my division. So my quotient is x minus 2. That's the quotient function. And the remainder is this time a degree 1 polynomial, 4x plus 11. And since the problem was not given as a dividend divided by the divisor, it was given as a fraction, my answer will be in the fractional format. So we'll say the answer to 5x cubed minus 9x squared plus 6x plus 3. Let me write the 6's a little clearly. Plus 6x plus 3 when divided by 5x squared plus x plus 4 should give me the quotient by itself. And remember, the quotient is simply x minus 2 in this problem, plus the remainder, which is 4x plus 11 over the divisor, which is 5x squared plus x plus 4. And that will answer my question. Now we can do a similar work to change the complexity of a long division, but I still keep doing the same thing, and it is called a synthetic division. So what I will do, I will actually start working on synthetic division, and while doing it, we will understand it together. So let's keep the workout problem. You will see it yourself. So this one is saying that divide x squared plus 3x plus 6 by x minus 5. First thing first, you will have a complete polynomial. So if there were terms missing, you have to insert them. Now remember, this one, there is no term missing because you have the 2 degree term, 1 degree term, the 0 degree term, the 1 degree term, the 0 degree term. So I can start dividing. So when you are dividing, say I'm dividing by x minus 5, so we'll say dividing by x minus 5 is doing the synthetic division by x equal to 5. So it's basically you solve the factor, that is the divisor, for the value of x. So I'm dividing by x equal to 5. So let's start doing that. So what I do, I write down the coefficient of the dividend polynomial, which are 1, 3, and 6. And then I write down the solution of the factor of the divisor polynomial, which is 5. The first coefficient, I don't change anything. Then I start multiplying 5 with 1 and I write it under the next coefficient. I add them always, so I get 8, and then I multiply 5 and 8, get 40, write it under the next coefficient, and I get 46. Since I'm done with all the coefficients now, I will stop and I will say the rightmost column, which is this one, is going to generate the remainder. So this is the remainder of the division. What is the quotient of the division? The next term from the right, you are going to multiply by x to the power 0 or 1. Add with the next term multiplied by x to the power 1. And if I had more, I would multiply by x squared, add, multiply by x cubed, add, and so on, so on. So what I have the quotient of this division as 1 times x to the power 1, so that's it, plus 8 times 1, which is x plus 8. And the remainder of this division is 46. Answers my question. So this is as simple as the process of long division in terms of synthetic division. Okay. The most important theorem in this section is the remainder theorem. What does it say? It says that if the polynomial fx is divided by x minus c, then the remainder of the division is f of c. So for example, if given a polynomial in example 3, fx equal to 5x cubed minus 6x squared minus 7x plus 4, I am interested in finding f of negative 3. I will like to divide the given polynomial fx by x minus 3, which is x plus 3, or simply do the synthetic division by negative 3. So if you look at the polynomial given, it's a cubic polynomial. You have the 3 degree term, 2 degree term, the 1 degree term and the 0 degree term. So it's a complete polynomial. So I can start doing the synthetic division. Remember, I'm trying to find f of negative 3. What I said, write down the coefficients only. And this time I don't even have to think about the quotient. I just need the remainder when I'm doing the synthetic division by negative 3. So long division by x minus negative 3, which is the factor of x plus 3. But synthetic by, when you set x plus 3 equal to 0, you get x equal to negative 3. So synthetic by negative 3. First term, don't change. Then multiply 5 with negative 3, put it under the next term. It should be negative 15. Add, you get negative 21. Do the multiplication again. Negative 3 and negative 21 will be positive 63. Write it under the next coefficient. Negative 7 positive 63 is 56. Multiply by negative 3. So you get 3 times 6 is 18. 3 times 5 is 15 plus 1 is 16. So negative 168. When added, I get negative 164, and because I'm running out of the coefficient, I will stop. Remainder is the number obtained in the last column. So that is the remainder of this division. What does it also say? You wanted to know f of negative 3, and that should be negative 164. You can also find this value in a little different way. Remember, to find f of negative 3, all I needed to do is replace x by negative 3. So let's try doing that to see whether I have done this work right. Negative 6 times negative 3 squared minus 7 times negative 3 plus 4. So 5 times negative 3 to the power 3 is negative 27. Minus 6 times negative 3 squared is 9. Minus times minus is a plus 21 plus 4, which is 5 times 27 is negative 135. Negative 6 times 9 is negative 54 plus 25. So let's simplify this quantity. So I get negative 189 plus 25, which is negative 164. So in either way, we got the same answer. So both of my works are right. Use the synthetic division and the remainder theorem to evaluate P of C, where C equal to negative 7. So evaluate the function, find the output when the input is negative 7. So I will do synthetic division and find the remainder. See, I'm dividing a 4th degree polynomial where you have the 4th degree term, the 3rd degree term, the 2 degree term, the 1 degree term, and the 0 degree term. So everything is complete. We can start dividing. Negative 7 is dividing the coefficients 1, 7, 1, 8 and 14. First coefficient doesn't change. Then I multiply negative 7 with 1 and get a negative 7. Write it under the next coefficient. Add them, you get 0. Negative 7 times 0 is 0. So 1 plus 0 is 1. Negative 7 times 1 is negative 7. Add 8 with negative 7, you get 1. Negative 7 times 1 is negative 7. Add 14 and negative 7, that is 7. And the last block is going to give you the remainder. So we have found the output. So when the input for this polynomial P is negative 7, the output is positive 7. And that answers this question. So now we are going to extend the study a little bit in terms of finding the solutions, real solutions for given polynomial function. So for a polynomial function, a possible set of rational zeros is given by the factors of the constant term, which is this, divided by the factors of the leading coefficient, which is this. And I will take positive, negative, both types of factors. And this set is going to give us the possible set of rational zeros. So let's do a problem. This problem, first I ask you to find the possible set of rational zeros and then use them to find all the zeros for the polynomial. So let's find all possible rational zeros. Remember, the constant term in this polynomial is negative 15 and the leading coefficient is 1. So when I'm writing the possible set of rational zeros, I start with all factors of the constant term, so 1 and negative 1, divide by all factors of the leading coefficient, and leading coefficient is 1, so the only factors are positive or negative 1. 15 is also divisible by 3, so plus or minus 3 over plus or minus 1. 15 is divisible by 5, so plus or minus 5 over plus or minus 1. 15 is divisible by 15, so plus or minus 15 over plus or minus 1. So what I have, essentially I have plus or minus 1 from first one, plus or minus 3, plus or minus 5, plus or minus 15. So these are all my factors. Now to find all the real solutions to this given polynomial, we will try each of these rational zeros till I get the first solution. Now remember, a solution makes the polynomial output 0. That is, the remainder must be 0. So when I do the synthetic division by these possible rational solutions, the remainder of the division must be 0. So let's start with 1 and see how much is the remainder. It's a 3-degree polynomial. I have the 3-degree term, 2-degree term, 1-degree term, and the 0-degree term. So complete polynomial: 1, negative 1, negative 17, and negative 15. And I'm dividing by, I'm trying 1 first. So 1 times 1 is 1, negative 1 plus 1 is 0, 1 times 0 is 0, negative 17 plus 0 is negative 17, negative 17 times 1 is negative 17, so that's negative 32 as a remainder, and this is not equal to 0. So 1 is not a solution to my polynomial function. How about negative 1? Same polynomial, we're going to divide by negative 1 this time. So let's start. 1 without change, 1 times negative 1 is negative 1. So that's negative 2. 1 times negative 2 is positive 2. So that's negative 15. Negative 1 times negative 15 is positive 15. And that is 0. As soon as I get that, I say negative 1 is a solution. So negative 1 is a solution. I found one of the solutions, and I know that there could be 2 more because the degree is 3. How do I find them? Well, what is the quotient? The quotient of this given polynomial division is going to be, remember, we are supposed to multiply 1, add, multiply x to the power 1, add, multiply x squared. So what I get? I get 1 times x squared plus negative 2 times x plus negative 15 times 1, which is x squared minus 2x minus 15. Set it equal to 0 and find the solutions. Now fortunately this is a quadratic equation, so I can factor. In fact, you were needing 2 numbers that multiplies to negative 15, adds to negative 2, and those numbers are negative 5 and positive 3. So I get to say that this is x minus 5 times x plus 3 equal to 0. So what are the solutions? X equal to 5, x equal to negative 3. So I found the solution set. If someone asked me to write down the solution set of real solutions, I would say, well, writing in increasing order, the lowest possible solution is negative 3, then negative 1, and then positive 5, and I'm done. And we're going to try to understand this process by doing a couple more examples. Our next example is given the polynomial, a cubic polynomial with the 3rd degree term, 2 degree term, 1 degree term, and 0 degree term. If you know one of the solution is 2/3, can you find the rest? So let's start working on this. So because the solution is 2/3, I know the remainder when I do the synthetic division by 2/3 must be 0. And the coefficients are 24, negative 46, 29, and negative 6. So let's see what we get. First doesn't change, and then I'm going to multiply 2/3 with it. So if I multiply 2/3, remember 3 cancels 24 gives you 8. 2 times 8 is 16. In fact, let me do it one more time because I want to keep this 24 over here, and I will do the calculation separately. So first is 24 times 2/3. 3 divides 24 gives you 8, so you get 16. That goes up. Well, now I add them and I get negative 30. And again, I need the calculation. Negative 30 times 2/3. 3 divides negative 30 gives you negative 10. Negative 10 times 2 is negative 20. So you put it up. Negative 20. 29 minus negative 20 is 9. So now I do 9 times 2/3. So 3 divides 9 gives you 3. 3 times 2 is 6. That is going to go up. And remember, we should have had the remainder equal to 0, which is true. So 2/3 is a solution. And I knew that because it is given to me. But what it has done after the synthetic division, it has given you the quotient. Multiply 1 with this term, add x to the power 1 multiplied with this term, and x squared multiplied with this term. And say the quotient now is x squared, actually I should say 24x squared minus 30x. How come? Because the coefficient is negative 30 plus 9, set it equal to 0, and now quadratic equation, so you can factor. So one thing you can do, if you observe that all 3 of 24, negative 30, and 3 has 3 as a common factor, you can divide by 3 and make the numbers a little smaller. 8x squared minus 10x plus 3 equal to 0. So then divide both sides by 3 and you get 8x squared minus 10x plus 3 equal to 0. Now what? I'm going to factor, so I multiply 8 and 3. So now I need two numbers that multiplies to 24 and adds up to negative 10. And clearly the number are negative 6 and negative 4. And then I factor by grouping. So I write it as 8x squared minus 6x minus 4x plus 3 equal to 0. So factoring out 2x from the first pair of terms, I get 4x minus 3. Then I factor out negative 1 and get 4x minus 3 equal to 0. Factor out the group of term 4x minus 3 and you get 2x minus 1 equal to 0. So either 4x minus 3 equal to 0, which means 4x is equal to 3, which means x equal to 3 over 4, or 2x minus 1 equal to 0, which means 2x equal to 1, or x equal to 1/2. So I have all three of my solutions. One of them was given to me, and when asked to write down the solution set, the lowest solution is going to be 1/2. Then the given solution 2/3, and then the one we have found out as 3/4. Answers my question. So the next set of problems, what we're going to do, we're going to create a polynomial that satisfies a certain given condition. So this time, the polynomial should be a polynomial of degree 3, it has a root of multiplicity 2 at x equal to 1 and a root of multiplicity 1 at x equal to -5. So what I say, I first make a little table. Root, multiplicity, and hence the corresponding factor, because these factors when multiplied would give you the polynomial. So see, the root is x equal to 1, multiplicity is 2. So you first subtract 1 from both sides, that is the factor. Multiplicity 2 just means a square. Then I have root equal to x equal to -5, subtract -5 from both sides or add +5 on both sides. Multiplicity is 1, so you get x plus 5. So I will say the polynomial that I'm trying to find out is the product of these factors. X minus 1 squared times x plus 5. But because I do not know the leading coefficient, I go with a. And how do I find the value of a? Remember, there is one other information. Y-intercept is y equal to -1. So if I put 0, then that must give you the y-intercept -1. So let's put 0. You get a times 0 minus 1 squared times 0 plus 5, which is -1 squared times 5. -1 squared is +1, so that's 5a. So what I have now, I have -1 equal to 5a, so a equal to -1/5. And I have my polynomial function. My polynomial function px, now I can replace the a by -1/5, and the factors are x minus 5 squared times, or actually this is x minus 1 squared times x plus 5. And that is the required polynomial. Okay, let's see whether we can do a couple more problems of this type. This problem in number 6 tells us there is a polynomial of degree 4 where the solutions are -4, 0, and positive, say 1 point. So this is 1, 2, 3, 4, 5, 6. So, and 1. So 0, 1, and -4 are my solutions. So there are 3 solutions, but the degree has to be 4. Well, remember, the solution 0 is even multiplicity. So that is going to tell me what should be the multiplicity of each 0. Okay, so the table that we're going to form is going to have zeros, required multiplicity, and factors. So let's start with the leftmost 0. The leftmost 0 in this situation is -4. So the factor will be x plus 4. And multiplicity should be odd because the graph is crossing the x-axis. So I can start with 1. If it doesn't work, we will come back and change. The next 0 is x equal to 0. So the factor is x minus 0, so x. Multiplicity should be even because the graph is not crossing, it's touching and bouncing back. And again, let's start with 2. If not, we will change it. The third solution is x equal to 2. Multiplicity is odd because this time you are crossing the x-axis. So we will start with 1 and the factor will be x minus 2. Because the multiplicity of 0 is 2, I should say x squared. Now let's just add the multiplicity to get the degree. 1 plus 2 is 3 plus 1 is 4. And remember, I wanted a 4th degree polynomial, so it is good. So now you can write what the form of fx is going to be. It's the leading coefficient times the factor x plus 4 times the factor x squared times the factor x minus 2. I want to know how much is a. To find it, I'm going to use the other information given that the graph of the polynomial goes to the point 5, -135. So when the input is 5, the output must be -135. So output is f of 5, which when you replace x by 5, you get 5 plus 4 times 5 squared times 5 minus 2. So -135 is equal to a times 9 times 25 times 3. So let's see how much we get. 9 times 25 times 3. So I will get 9 times 25 times 3 equal to 675. So now I have negative 135 equal to 675a. To solve for a, I will divide both sides by 675. And I will get a equal to, well, let's divide the top and bottom by 5. So you get negative 5 times 2 is 10, 27. The bottom is going to be 1. And 5 times 3 is 15, 25, so 135. And I guess I can divide both top and bottom by 3 as well at this point. So let me check my work on this one, actually, to make sure that I did it right. And it looks like it is right. So now what? Now we are going to divide by top and bottom by 3. So I will get negative 9 over, when 3 divides 13, you go 4 times. 15, so I can divide it by 9 again on top and bottom. That's easier to see, and that will be negative 1 over 5. So a is negative 1 over 5. Hence the polynomial that we wanted to find out is negative 1 over 5. Write the x square in front, x plus 4 times x minus 2, and that is the required polynomial which will have the given graph and will pass through the point 5 comma negative 135. Answers your question. Okay, our next problem, we have 5 different graphs and 5 different functions. We want to understand which one is for what. So if I look at the first function, the degree of this function is going to be 4. Degree is 4. Leading coefficient, let's call it LC. Leading coefficient is clearly 1. And that is positive. So even degree, positive leading coefficient means both ends will go up. So that will be one of those pictures where both ends are going up. Now to understand the solutions to the first equation, you will factor the inside, and the factors are going to be x minus 3 times x plus 1. I'm not showing you the work, it's pretty simple. Then remember there was a square outside, so I'll put squares everywhere. So the solutions to the first one is 3 comma negative 1. So that is just the first one. The second one, the degree is 3 plus 1 plus 2. So that is 6. And that is even. Leading coefficient for the second one is 1/3, still positive. So it is the same way, both ends are going to go up, whereas the solutions are a little easy to find out. It should be 0, odd multiplicity, so 0 I will say cross, and then the next one is solution is 2, odd multiplicity, so cross, 3 is even multiplicity, so that should be touch. And whereas the previous one, both of them were even multiplicity, so both of them would be touch, and that's number 2. Number 3. Number 3, again, finding the solutions, you will require to factor. So you can take out x squared from the first 2 terms, get x plus 3, and then you can take out negative 4, get x plus 3. So it is x plus 3 times x squared minus 4. If you remember, we factored it previously by writing x plus 3 times x squared minus 2 squared. So I get x plus 3 times x plus 2 times x minus 2. So the solutions are negative 3 odd, so cross, negative 2 odd, so cross, 2 odd, so cross. So all solutions you will cross. Also, it is degree 4, so even. Leading coefficient, actually this is degree 3, I'm so sorry. Degree 3 is odd. And its leading coefficient is 1. So left end goes down, right end goes up. That's number 3. Let's do the work for number 4. Number 4, degree is 3 plus 1, so 4, that's even degree. Leading coefficient is 1/4, that's positive, so both ends should go up. Solutions are easy to find out. They are -1 odd multiplicity, so cross, and +3 odd multiplicity should cross as well. And there is one more, the last one. So again, I will require to factor first. So when I factor, I first identify that I can factor out x, and I will get -2x squared minus x plus 1. So x times -2x squared, because you needed two numbers to multiply, give you -2, and to give you -1. The numbers are -2 and +1. So I write it as -2x squared minus 2x, +1x, and then +1. So factor out -2x first, you get x plus 1. Then +1, you still get x plus 1. So that is the factors that we are going to find is x times -2x plus 1 and x plus 1. So I know the solutions now. So the solutions to this one is going to be x equal to 0, x equal to -1, and -2x plus 1 equal to 0 means x equal to +1/2. And all of them are odd multiplicities. So at all of them, we are going to cross the x-axis. Leading coefficient in this problem, remember the leading coefficient is -2 in the fifth polynomial, less than 0. Degree is 3, and that's odd. So the left end of the polynomial will go up, the right end will go down. Left end go up, right end go down, and there is only one of them, and that's the fourth one. So this is the graph for the fifth function. And see the solutions here. The solutions are -1 crossing, 0 crossing, 1/2 crossing. So matches. The rest of the four are all, there are three of them that are both ends going up. If I look at the first one, I find solutions are at -1 and +2, and both of them are even multiplicity, both ends goes up. Remember, that was the first situation. -1 and +3 are your solutions. Both of them are even multiplicity because it is touching and not crossing, and both ends are going up, so this is the first function. The second one, the solutions are at -1 and at, let me see, it's going to be 1, 2, 3, -1 and 3 are my solutions, but both of them are crossing, so it should be odd multiplicity. At both ends I'm going to get odd multiplicity. So do I have a situation like that where the solutions are going to be -1 and 3, and that's number 4, isn't it? -1 odd multiplicity, 3 odd multiplicity, and both ends goes up. So this is graph number 3. The next one, the solutions are at 2, -2, -3. So these are my solutions. All three of them you're crossing the graph. So it must be odd multiplicity at -3, -2, and +2. Hence, this is the graph for the polynomial function in number 3. And the previous one was polynomial function in number 4. I'm so sorry. That was both multiplicities odd at -1 and +3. That's number 4. Okay, so the last one is both ends going up. But this time, the solutions are at -3, at 0, and at 2. -3, 0, 2. At -3, it's odd, 0 even, at 2, odd. So let's look at number 2. Solutions are 0, you will cross, so odd. 2 is going to be crossing, so odd. 3 you will touch, so even. So that's exactly what we have. and both ends are going up, so this is number 2, and that answers this question. And this also ends our study for polynomial functions. Next class we will start talking about rational function, and then we will combine them in our 4th section, which is solutions to inequalities involving polynomial and rational function.